the Hadoop platform and how Hadoop is the choice of platform for the big data challenges. That transition will take in the next 2 days, next 3 days. Once we set the level, and then we'll discuss about Hadoop architecture, the core subsystems in the Hadoop, and then we'll move on to the popular frameworks inside Hadoop, like Hive, Pig. Yesterday I was showing one content to you. So today we'll start the class. If you want, I can run through the slides again after the class. So let us start today. Now, okay. So just touch upon some of the concepts around big data, so that with this context we'll look at the Hadoop as a platform to be big data use cases. So if you look at the traditional warehouses, what typically you see there is most often you see the silos of the repositories there. They could have been categorized by the domain, like say by technology stack, MySQL, DB2, like that, or they could have been categorized by the domain spaces, like ERP or something like that. So you have multiple such repositories where they bring up to some level of denormalization from the source systems, and the objective they would have is that either the warehouse will be like a central repository where the culmination of all the repositories can exist together, and the end output is that either they do some analytics works on top of it, or they do some MI as part of the monthly management information systems, right? Let us say if you are a kind of a supporting platform for many other customers, then you most tend to do MI as part of it. But if you are a corporate of your own and wanted to build the intelligence around it, then you would go for analytics part of it. The consumption depends on the kind of business model we are operating in. But the essence of the warehouse is that we have the collection of repositories. There we would have a known schemas. Of course, they don't completely comply with the normalization. They do some sort of normalization to fit to the reporting and other purposes. So this is a typical structure what you see in the data warehouses, right? Now if you move on to the next one, so now we're talking about big data. So how that is a way ahead or completely different shift in the way the warehouse being operated. If you look at by definition, it talks about key points. One is that the data is a distributed one and aggregated one and also loosely coupled one. That's all the definition about big data. So it is not talking about a data which is there as a contained data, and it is not talking about data that has not been enriched. It is also talking about data that has no relevance in the data. Three sets of dimensions it is talking about. The rest of all the explanation of the same definition. But the loosely coupledness means you don't have much structure, defined structure in that. And aggregate data is that it is a data which generated from many sources. Could be a simple transaction system, could be a machine, could be a sensor, it could be many things. But data has been collected from many such sources, and often it's a distributed one, and at a huge volumes. So those fundamental aspects this big data is talking about. If you define further to quantify the to clarify the definition, it talks about flat schemas. You know, this is something we haven't heard in the SQL traditional DBMS world. All that we see is the known schemas. You know, there is a table that has defined columns, and columns have a known data types. That thing goes on. That is what we have been seeing it. But here talking about flat schemas means there is no much significance on this schema, and there is no much the relational integrity in the schema. It's all you just have a row and column, and that doesn't have the integrity in its own stand like that. And often it's a loosely coupled data, loosely structured data. You are seeing it. Other important concept from big data is that is incomplete data. That's where the warehouse get puzzled with this kind of concepts. You know, volume is not a deterrent factor in the warehouse. There are warehouses that are handling terabytes of data, but the deterring factors in the warehouse is that the loosely structured data, the flat schemas, incomplete data. So why we have to deal with these aspects in this current time? The reason is that we'll see in the coming slides. So far, what we see in the warehouses are it's all a known data, known schemas, and we're dealing with this. But because of advent of many such technological advancement, we are seeing all these new dimensions now. So with these dimensions, big data has emerged, right? Now, so the dimension just now we talked about is that the volume, variety, and velocity. These are the fundamental dimensions here. Let us look at each one of it. So the volume is pretty much, we can understand it. We are not completely unfamiliar with the data volumes, but again, the volumes we're talking about is much beyond the current limits. Even if you say current limits they are reached up to the terabytes and beyond that, and then we're talking about volumes that go beyond terabytes, like exabytes and petabytes and exabytes, like that. That is the volume we're talking about it. And yeah, this is the table that gives you the size of it. You know, so much of volume being generated now. There are obvious reasons here, are there, right? Even the IT industry, it has been there for the last 25-30 years. So there is no such company exists today that doesn't have information systems in them. So all of them have matured a lot. They keep on adding maturing systems according to the business changes. So in these 30 years, a lot of changes have happened in the industry, and for each and every single purpose, there is a customized applications now we have. Apart from the corporate level applications, enterprise level applications, for individual small goals also we have a dedicated applications now. That is one factor. Second is that, you know, you see in coming slides, you can easily guess that the growth of the volume here. In many forms, you know, you see the data volume being generated right from the enterprise application. That's where the actual IT usage started, but that percolated to the other industries. You know, one of the major contributors is social media, the feeds, blogs. Pretty much these are very obvious to you. I don't have to spend much time here, but because of these new avenues, you know, the huge volume being generated, and this is one of the by definition, if you go by the big data, by definition of big data, if you go it, these are the fundamental the design objectives the big data technology should be able to address it. Not that volume is something that is a deterrent in the big data, but the wide variety of sources, they really put a challenge to the warehouse industry. That's when people started out alternatives, and then big data emerged. Alright, and the velocity. See, having volume can be accommodated, having the multiple sources can be accommodated. But now we're talking about velocity. We are we are trying to approach near real time or real time. So that means that as the incident occurs, you could able to process the data. Typically, if you look at the warehouses, what the scenario is that you accumulate data from the sources, do a refinement job or denomination job, and then run reports. MI is basically like that, right? We define it for monthly or weekly or like that. That is a kind of gap, the periodicity we used to have in the data accumulation as well as data processing. But now people wanted to have more deeper insights in the data. People wanted to get the live information about the transactions, what is going on in the industry. So it is that the objective is that more and more organizations trying for the real-time processing. That's where the real challenge comes in also, along with that. So your systems are earlier designs were not capable of doing real-time data processing. So this is where Hadoop big data, big data, pitching in and promising for the solutions for it. Okay. Now the fourth dimension is emerging, but it is not completely yet as a primary factor in the big data, the veracity. The kind of incompleteness, the kind of ambiguity, the kind of deceptive data, those things are emerging in this thing. If you look at by the definition of big data, we're talking about loosely coupled data, right? And also incomplete data. This is one of the fourth dimension. It is emerging because of the earlier factors, the social media, censored data. So you can't in the big world, even though if you apply standards also, this is not guaranteed that every industry or every organization would adhere to the standards. There could be obvious reasons. One is that there could be political reasons. There could be their business model might not fit into the standards, or they may not find value, or even time and money and effort to adhere to the standards. So because of that, the wide variety in nature we have, in diversified world, those standards can be applied. It is not guaranteed that always it is followed. So because of those reasons, veracity is the obvious dimension. So the context I'm saying is that let us take healthcare industry. In America, HIPAA is there. That is the regulatory authority of the healthcare. They define the formats for all transactions happens in healthcare. Let us say if somebody goes to doctor and avails the service, they file a claim. There is a format for it, 837. For organizations, 837I. For the patient, 837P. The defined formats are there. And it is expected that all the insurers and the providers, doctors, or the hospital clinics, facilities, they must have to adhere to the 837 format. But that's not guaranteed. So what they do, they adhere the 837 format at high level, but they take deviations in some of the segments in the 837. That's how the world is. Take any industry or any vertical or any horizontal. There could be some deviations to fit into their own business model. So this is very obvious in the current world, and because of huge data being generated, veracity is one more big puzzle. The technology should be able to address it. So big data also includes the veracity in its coremost dimension, right? So this is all the intro part. We're not discussing about Hadoop so far now. So this is obvious image what we can see. Many sources, many kind of patterns, many kind of formats, and huge velocity being generated now. And now there are many companies trying to solve specific problems. Gone are those days that there is general company tend to give a generalized solution, you build customized one, not like that. Nowadays nobody is preferring to build a own customized solution. They want to buy it rather than build it. So there are many companies giving a very specialized solutions on the big data wave. And there are existing companies, they are transforming into big data world now. So this slide basically give an insight to you that we have very specialized categories now compared to 10 years earlier. Now this is interesting one. This should give you insight about how this wave is going on and what are the catalysts in the big data wave. So even if you talk about so much data being produced, so many varieties are there, and so much of veracity is there, we are still at the at somewhere mid path of the data volume tsunami. So in the coming days, because of these technological support, there will be a lot of such data emergence, that variety emergence, that volume, that veracity emergence would see. And you see the obvious reasons here. The green part is sensor data. And nowadays more and more companies leaning towards instrumentation basically, right? Even if you take a simple car, like a mid-range car, that has many sensors now. And sensors collect a lot of data and they push it to the centralized server. So that level of automation we are bringing in. Even now, the device called Fitbit, you would have heard in US, it's coming to India now. That device basically collect your exercise data, how much distance you walk today, how much calories you burn today, and that actually through Bluetooth, you can, that Fitbit to GPS, it pushes data to the centralized server, and you can have an app in your mobile. From that you can continuously monitor it, how your the health check is going to happen. So the point trying to bring is that a lot of automation is happening in this. Because of that, sensor data is inevitable in the coming days. And when you talk about sensor data, it's all combination of incompleteness and variety of data, right? And obviously social media, it is the one of the catalysts in the current wave, still be that in coming days as well. Even the VoIP is going tremendously, it is nothing so far compared to now. Only in America this is a prevalent use of VoIP, but as in many countries, they see value in VoIP investment, and they want to reduce the cost on their the existing radio-based technology. They would go to VoIP. That's where many things are happening now. Obviously enterprise still be continuing it. They still be adding more and more applications in coming days like this. So this is just a give you an insight about the kind of data we're looking at it. If various are dealing with the iceberg, big ice mountain, now we're dealing with big data at a hidden big iceberg here, right? The depth is almost unknown basically. Okay, so just give some thought process around cloud and big data. In the cloud, the buzzwords are the dimensions are now solution being offered as service, platform being offered as a service, and infrastructure being offered as service. Whereas the dimensions in the big data are volume, variety, and velocity. And there is a comparison also, not comparison, correlation I would say, that these two are not competing technologies but rather than a complementary technologies. So we are trying to correlate the dimensions what we see in big data with the cloud, like this here. And I'll skip this one, it's not much relevant to you. Yeah. So yesterday also I showed this slide to you. This is the snapshot of 4 years old snapshot about Hadoop and its big data contributions. Now there is emergence of different verticals now, analytics infrastructure, operational infrastructure. So people would like to process the logs, they call as operation infrastructure, like monitoring systems, fault detection systems like that. People would do the business insights, they would tend to be in the analytics infrastructure. And you know, people, the traditional systems, they revolve around the analytics and visualizations. They might not um, take advantage of the all the big data concepts. And the structured database we know from ages, like that. So the industry was trying to catch up with the big data some 4 years, um, 4 years before. But if you look at the current trend, so crowdy. So the takeaway from this slide is that no, there is hardly you see any company which is not catching up with the big data wave. So that is the meaning of this slide, you know. And more specialization has come. If you look at it, even if you look at data sources, earlier we have only a few handful of data sources. Now there is specialization here. Now, apart from the traditional repositories, we have specialized data sources now. Even if you look at the analytics solutions here, the visualizations here, and there is a new segment called statistical computing here. See this one, and crowdsourcing is there, and people moving to real-time processing here. So I'm not talking about the individual technologies here, but the point is that there are specialized and companies, every company which is part of the enterprise solutions offering or part of social media engineering, they are either catched up or they are already trying to be in the big data space, right? So this slide basically given an understanding about the various verticals we have and how industries are coping up. So the green ones are the ones that says that whether the industry has adopted it in production usage. This is not an experimental thing. So there is no such the high level, the important verticals which has not adopted the big data. So that gives us an insight to us. So the popularity of the big data and the need of it basically, right? And again, the growth, I think this I captured from the Forrester. Okay. Yeah, this is an important one. This will give you an understanding about where, even in the big data, where the opportunities are lying in. So this analytics space, the application development space is very thin in the coming days. So you don't see much new applications being developed in the big data space. So much of the scope would be there in the application infrastructure and the database managing softwares will have more scope here. And the integrations part, these things will have more scope here. And lastly, there will be some infrastructure software, I mean to say, monitoring tools, log processing tools, those will be there. So the point to take from this slide is that application infrastructure and middleware means these big data applications might not be front-ending with the customers. You know, the existing the mobility applications or the websites, whatever, they will continue. But behind the scenes, big data application will be the enablers or the enhancements of the existing application. That's where you'll see it. But you don't see a native applications being developed on big data alone and being offered to the customers. That you don't see in the coming days. And from organization's perspective, what is the challenge now? Staffing is the foremost challenge in the big data. Means people have the right skills in the big data is a scarcity now. Technology-wise, the affordability-wise, that phase has been passed. The technology has been proven. The affordability is, the cost has been reducing day by day. The integration with other systems in the ecosystem, that is also came down. The complexities came down. But the challenge is with the staffing. You know, so that is advantage for us. People who are adapting to this new technology stack, they will have more opportunities and brighter careers. Right? Yesterday also I showed this slide. This will give an idea. So why organizations are investing in the big data? So what the end goal they were looking at it. Currently, if you look at it, much of the companies, once their business model is stabilized, they would go for some reporting tools. Either they purchase some tool or they build their own MI systems and have reporting. And once they are matured in the reporting model, they would go for the OLAP-based models here. They build some cubes and stars and with dimensions and generate some reports. But more often, these two are like correlated ones, aggregated reports. You have data, you have to aggregate data and bring some report from it. But if you look at the big data, the meaning and the objective organizations are looking at it, they want to get insight on the data. That's where the industry is heading it. So as the data is growing, they want to get a wide spectrum of analysis on the data. And this is not an easy thing. The complexity also increases as you want to process more and more data and we want to get different perspective on the same data, different views on the same data. So how do you get it? That's where the analytics is the natural cousin of the big data. That is taking advantage of the platform, big data platform, and is facilitating many wide variety of analysis which they could not have done earlier with earlier technologies. That's where the industry is moving on, and that's where the driving factor for the industry to put investment in the big data space. Right. I'm skipping it. Okay, so this is about the big data introduction part. All right. So any questions so far before I start the second session? Shall I continue with the second session?
Yeah.
Please stop me now if you have any questions. I'll discuss that. So having seen the context of big data, how it the need of big data has emerged. Now let us see Hadoop, how it is going to fit into the big data dimensions. Okay, so let us look at the fundamental aspects of Hadoop. It is started as a monotonous application and then emerged as a framework. So fundamentally it is designed to support data intensive distributed applications. That means that always the applications are dealing with data alone. What does it mean by data alone? Means all continuous, there should be some sort of processing is needed on the data. That is what the meaning of data intensiveness. And the data is distributed. So this is one term we might not have seen earlier. We have seen clusters, but we have not seen distributedness. If you are coming from any clustered architecture, say the clustered caching, if you are working with the memcache, or has anybody worked in memcache? Memcache clusters. Okay, if anyone has got experience in the memcache clusters or the IBM extreme scale caching or the Microsoft App Fabric caching, these are all clustered based caching, and they are meant for the distributedness. So what will happen is that your application needs a cached data. Say you are building an automobile application. So this application needs data of then car models, the engine types, the fuel types, the design aspects of it, the key features of it. this data doesn't change dramatically. No, only thing you need is that when car is being booked, you refer to that master data here. When car is being sold, you refer to the master data. Somebody searching on it, you refer to the parameters here to filter data. Other than that, this is like a master data on the organization or static data. So these kind of static data, and if it goes beyond GBs and terabytes, you can't handle them in simple database tables. That has to be put into the memory. That's where the clustered data architecture came in. You put up the multiple nodes, and we distribute the static data across the multiple nodes, and they'll have the replication factor also here. And the advantage is that they can with this distributiveness, they can accommodate huge data sets in memory and can quickly respond you back in milliseconds. So this is one of the design achievements happened in the clustering technology. So Hadoop some sort of leaning towards the distributiveness in the data. Okay. And the framework designed to cope up with thousands of nodes. Node means individual servers here, right? It is capable of dealing with thousands of nodes of petabytes of data. So the inspiration from the Hadoop is that it came from the Google's MapReduce and Google GFS papers. Basically, these two are talking about the huge data sets being distributed. When Google became popular, Google search engine became popular, and if you are coming from that if you have seen any kind of intro about Google's design, so fundamentally they have page ranking algorithm. Now they give rank to each other website page. When you search for some keywords, lot of things involved in that, but ultimately the core of it is the page ranking. So one is that the semantic analysis of the data, the query. Let's say in Indian context, if I say get me the price of some phone, let's say Samsung is launching a new phone, I do a googling, Samsung XYZ model price online. I'll give that query string. So there will be lexical parsing of the data that will be there. But after that, how to pick up the relevant pages, it's all based on the page ranking algorithm. So each web page will be given a ranking for it. The ranking is based on many parameters. So the topic to discuss now is that in the page ranking algorithm, two things are there. One is to retrieve the website, right? We have to retrieve the website. Second is that how to get to that page residing in some disk or somewhere. So this file system talks about it. It's a distributed file system. It is all based on the redundant disk arrays, RAID-based architecture, and it is fault tolerant, always available. You can get to a document in milliseconds, and then the page ranking algorithm also. It is inspired by the Google MapReduce framework. Google is the first one to experiment with the MapReduce algorithm, and then they renamed this MapReduce as a page ranking algorithm. So with these two, I'm going to discuss these things in a minute. But I'm just giving you some background to this Hadoop word. So when they got success, they published their high-level architectures as white papers in the industry, and that's when things have started. That's when the person who developed the Hadoop was really excited to see these papers, and he started about addressing new challenges from these papers. Okay. This is the context behind it. So when Google published the papers here, this gentleman called Doug Gutting, he was working for a company called Lucene. He was working on a project called Nudge, and he was developing some search engine called Lucene, and that search engine basically trying to give a It is not based on lexical searching, but rather than natural language processing based search algorithm that he was developing it. So he's finding very difficulty in this framework. So when this Google published this papers, he found very interesting, and they offered as a open source. Anyone can use their architecture. That kind of model they published it. So this gentleman picked up this GFS and MapReduce, and he enhanced all these existing frameworks, and then the redesigned the Nudge project here, which Lucene is offering it in 2004. So that's when the birth of the Hadoop has started, but it's still being called as NUT at that time. So when they had success inside the organization, Yahoo came to know about the architecture, and they wanted to, and Yahoo was actually having tough competition with Google. So they want to try out very different things so that they can beat the Google in the search industry. No, then they invited the Cutting and the team into the Hadoop. They joined with them, and that's when they evolved this framework as a highly scalable distributed framework like that, and things started like this. And they want to give a new name for the framework. Hadoop name was coined because Hadoop is a toy. The Cutting son is playing with a toy elephant. Its name is Hadoop. So he picked up, that is very interesting and unique. Somehow the correlation happened, and then picked up the name. So that's when in 2006 the real birth of Hadoop has started. And underneath the ideas entirely they took from GFS and MapReduce papers of Google. And when this Yahoo, this is the company that took the 100 node Hadoop cluster, and they had a very good success. In fact, they were trying to catch up with Google. But off late, now if you see Yahoo, they are nowhere because of some they have some their organization issues. But that time they were trying to catch up with the Google. And then Facebook realized the potential of the framework, Hadoop framework. This is the first outside of Yahoo is the company that implemented the Hadoop, and they find difficulty in using Hadoop and its APIs. So they want to make it more generalized. They contribute Hive to the, they give a SQL kind of usage to the Hadoop, and they offered a new project on top of Hadoop. So like that, many companies started it. So the journey continued in 2008. Till the time, it is all Apache open source offering only. There is no support. As you know, in the Apache there is no support. And Cloudera was the first company. They took the Apache Hadoop code base, and they developed a new distribution called Cloudera Hadoop distribution, and they offered it. It is under the same Apache license, but they give support, and they enhanced it, some tools, administrative tools around it. Nice UI they built around Hadoop, and with that, they showed the corporates, enterprises that there will be a kind of a professional support is available for the Hadoop technology. This is the real catalyst of the Hadoop adoption inside the enterprises. Till no enterprise, big enterprise, was looking at the Hadoop, but they never adopted it. So this is a brief story about the Hadoop. So what are the characteristics of Hadoop? We can see it is accessible. I mean to say, accessible from many areas. You could directly hook up to Hadoop through TCP/IP, through web interface, or through other means other protocols. You could even connect to the XML-based protocols, REST-based protocols, or if you look at the payload-based one, or you look at the transport level protocols, TCP/IP or HTTP. So even the piped architecture also will work with Hadoop. So it's accessible. Being it is a large cluster of individual nodes, it is accessible, and it is robust, scalable, simple. Data locality parts are there. I'll discuss it in a minute. So I want to give these jargon words because this is very important in the coming sessions. I'll be using this terminology quite often. So just look at the important ones. The data locality part. So one of the key part in Hadoop is that we are dealing with huge data sets of beyond gigabytes. So unlike in the RDBMS world, what will happen is that data moves or data being collected to data being collected for a query. But whereas in Hadoop world, data will be never collected. Data will be local. Means data doesn't go anywhere. It is the processing module that comes to the data, does the processing where the data is there, and then the results will be published. So that is the locality. We will see that part. And it is simple. How it is simple, you will get a realization once we discuss the Hadoop part. And it is scalable part. This is the important part. In the earlier I was using a word called Memcache or IBM Extreme Scale. Those things I'm using it, right? Those are all there from time. Let's say they're there from last 5 years, 6 years. Those are also scalable to some extent, but they can't scalable beyond certain limit. Say if we were to implement a 100 node cluster, they can't accommodate that because their architecture has a linear limit on it. Whereas Hadoop is not, it designed to be scalable of hundreds and thousands of nodes in the cluster. That is the scalability limit we are talking about here. And the other part is replication part. Replication is needed when you need availability. So no matter what the application should be available all the time, 24/7. If that is the requirement, replication is a mandatory in the architecture. Hadoop is supporting that. Hadoop is highly replicatable, and the replication levels also can be controllable. With this combination, Hadoop is a robust architecture. It is conforms to the clustered concepts. It conforms to the availability concepts. It conforms to the scalability concepts. And yet it is simple. That part we'll see. Yeah. So what are the main drivers in the Hadoop? From the business owner's perspective, they want to get higher value in terms of intelligence, in terms of insights from the huge data sets. And for the stakeholders who fund the technologies, for them, Hadoop is a cost advantage. They have cost advantage in this. For the same kind of data, if somebody goes with a traditional warehousing, the cost is much higher. I'll just give some numbers to you. In Hadoop world, to process to have 1 GB in its repository and to process, it takes $1 per GB. Whereas, sorry, $4 per GB. Whereas in traditional warehouse systems, if same GB has to be processed, it takes around $100. So that's the advantage the stakeholders will have. And for the technologists or the architects or the solution delivery managers, it is because of the factors we have just seen. It's fault tolerant, highly replicatable, it is scalable. Those are the driving factors in the Hadoop world. Right. So now, before we get into the Hadoop architecture, let us look at the comparison between RDBMS world. Because we are very familiar, most of you might have seen RDBMS systems for a while, or at least you would be knowing about it because that is there for a long time. So if you look at the RDBMS world, it predominantly talks about terabytes of data, but it is now going beyond terabytes and touching the hexabytes of data. So access is interactive most of the times. You fire a query, immediately you get a response in millisecond or sub-second. But it's not like that, no, it takes ages. It's not like that. But whereas in Hadoop it's all batch mode, it's not interactive. You submit a job. You don't submit a job and you have to come out. And after a while, again you have to go to the Hadoop system and inquire about the job, whether that job has been done or not. So that in that sense is it is not interactive, it's a batch model. So this is one of the key aspects is that In the traditional systems, read and writes are pretty much anticipated. You write insert data, read data anytime, update it anytime, many times, any number of times. Whereas in the Hadoop world, that was not the objective initially. Ingest the data or import the data into Hadoop means write the data in the Hadoop once, and then it is not subjected to the updations frequently. The main objective is read it as many times you need and in different formats. But it is not highly supportive for updations of data because of its architecture. But now this is the architecture some 3 years ago. But now the architecture is maturing it, and it is trying to accommodate what the traditional systems are doing now. Read and write semantics also now being imported onto the Hadoop. We'll see that part. In the H-based discussion, we'll see this part. But if you look at as is Hadoop, it is only meant for write once and read many times. Why that why that is significant thing? We'll see that in a minute. Yeah, schemas. This seems to be a kind of limitation on a Hadoop. But look at the other thing. This is the advantage here. Schemas are pretty much well defined in the DBMS world, like static. This is the power in the Hadoop. This is dynamic. It doesn't enforce any schema restrictions when you're ingesting data. Today, if you're ingesting data of 3 columns, and tomorrow if you're ingesting data of 4 columns, it doesn't stop you, nor the applications consuming the Hadoop doesn't fail. They can accommodate the schema. That means it's schema agnostic designs. It is following it. So this is the strength, particularly when you're talking about the data sources which cannot conform to the particular standards. The dynamicism of schema is a kind of boon in the organizations. Coming to the ACID transactions, ACID level of compliance, RDBMS is for the ACID compliance. The integrity, the atomicity, the consistency, and durability, right? The ACID part, and that is pretty low. That is not the design motto in the Hadoop. Hardly it eventual consistent, but it is not ACID consistent. If you look at the Hadoop, this is called as an eventual consistent system. Means you can insert data. The data might not be pushed to the physical drive immediately. It might take some time, and it is not supporting transactions at this moment of time. So those are the aspects. Whereas transactions are the coremost thing in the DBMS world, whereas this is not the thing in the MapReduce, Hadoop, sorry. And scalability part. This may seems to be some kind of downplay for the Hadoop. May seems to be, but this has obvious reasons why they are not, why they have not designed the ACID in the Hadoop. They have their own reasons here. We'll discuss that part. And scalability part. Pretty much linear. There is a limit on the linearity. It is linear, but there is no limit on it. You can have hundreds of nodes in a cluster. Right? And the latency part. It has latency because of batch model. It has latency here. Please feel free to stop me if you're not catching up the words here. I can explain in detail if you want it. The ACID part of it, the schema part of it. Are you all with me now?
Yeah.
Okay. What is the static schema or dynamic schema?
Okay. Static schema, just take a look at the traditional tables here. You have rows and columns here.
Okay.
So for this table structure, you would have defined a schema here, right? This is an integer, this is a string, this is a long, something like that. We have defined it.
Indexes.
So this definition is called a schema, right?
Table structure.
Table structure. That is a schema basically, schema of the table. So what is meant by staticness?
It's not changing.
Just recollect the DBMS word here. If we have to add a new column, or if you have to change the column type of it, or if you want to change the column length of it, just recollect the effort needed in the DBMS world. You have to first get it tested in the multiple environments, and then push to the UAT, user acceptance, and then if it's completely pushed to the production, then there should be the operational window, production system will be down for the window time, and this will be released into the production, and there will be testing will be done. So there is a lot of management overhead to change the schema. It is not a dynamic one, right? You can't, though you know command how to add a new column, you can't do it on the fly because the data is also need to adjust to the new column, right? If you're putting a new column here, how do you deal with this? Do you put nulls here or do you put some one value? You have to take a decision about these columns, right? You can't leave it blank. And what happens is that it fails at transactions level. Asset level will fail because when you're finding a query, it encounters null, it fails. So there should be some decision has to be made, not about the adding column, also how the default data, all the initial values in a new column are to be treated. So a lot of overhead involves in this schema because the consuming applications tightly bound to the schemas here, right? Tightly bound to table structure here. So when we are talking about dynamic schema, that limitation is no more the hurdle in this scenario. So the essence is that, let us say we have a table in the Hadoop, not in Hadoop, other day I was showing you Hive, right? But for the discussion sake, assume that there is a table in Hadoop and it has columns like this. And tomorrow you can add a new column without alerting anybody, even the consuming applications. How this wonder is going to happen? That is because Hadoop is capable of taking loosely coupled data and loosely structured data. That we will come to know. So this, the fluidity in the schema, the flexibility in the schema alteration is called dynamic schema. You can remove a column on the fly, add a column on the fly, without having all this management overhead on top of it. So that is the dynamic schema part. Got it?
Yeah.
Okay.
Yeah.
Yeah, some cost perspective, I'll skip it one. Let us complete the introduction part today. Tomorrow we'll get into the Hadoop architecture. So far we are trying to fit the Hadoop in the big data dimensions, how it is going to tackle it. In the dimension what we're talking about, the loosely coupled structure of it, the deal with the high volumes of data at high accelerated pace of production. Those things we have seen it. But are there any alternatives to the Hadoop? Is Hadoop the only one? There are alternatives. And Mesos is the architecture. That is the just give me a second. Okay, so Mesos is the architecture. This is also trying to solve the big data kind of problems. And I'll touch upon this one at the end of this course. The administration part is there. That will be meaningful to you once you understand the Hadoop architecture. And when you go through the Hadoop subsystems, then if you discuss the Mesos, that will be more sensible to you. Otherwise, it will be confusing to you in this part. And there is another framework called Spark. This is dealing with some sort of big data challenges in a different way. Hadoop deals the data in a locality aspect of it. Spark deals the data in distributed aspect of it. We'll come to these two architectures at the end. But let us move on to the Hadoop architecture discussions. Right. So I think we reached today's time. So tomorrow we'll continue on the Hadoop architecture and we go into the Hadoop use cases. and then we'll discuss the MapReduce architecture. I mean, not tomorrow, Monday. We'll discuss that. Any specific questions so far you have? Yeah, before you come down to the Monday thing, I would like you to, I would be sharing some of the refreshers here, Linux refresher and Java refresher. Please go through it. And also, I would like to, you need some preparatory thing. Just give me a minute. I like you to, so there's some yeah, this is the one you should have. I'll share this document to you. These are the essential things you have to download. The Hortonworks VM and the party tool, and you should have the VM player, the JDK version of it, the Eclipse version of it. They're all freeware. You can download on your own. I've given the links also. Download these things. I'll share this document to you. And also download the data sets, because that is these are the ones we will be using in the coming classes. These are decent data sets. You can play around with this easily. Yeah, this I'll share with you. And
the Hadoop tool is also is it in there or what?
Could you be little louder?
No, I'm saying, are you giving us the framework by itself, the tool?
Framework is a tool I can give, but of no use for you, because if you download the softwares, you will have the tool with you.
Okay, okay.
See, this is the one. If you download this VM, this is around 3.8 GB. This tool.
Okay, okay, okay.
If you download this software, you will have every setup, but you need data to play around with this. That's where you have to download the data sets. These are all some Excel CSV files, comma separated files, and they are of decent size. You know, this is a 800 file, this is 100 GB file like that, 100 MB file like that.
Okay.
So once you first go through the steps here, one after then the same sequence, and then have it ready. So next class I'll show you how to set up the environment in your laptop, and from there we'll take it on. We'll get into the hands-on. Soon we complete the theory part. Okay. Yeah. Any questions so far before we wrap up the class today?
Do we have any training material or something? Means like
sure.
Book which we can refer to.
Book you have. Book this is mentioned here in the same document. I mentioned the references. That books you can buy it or download it in the internet, whatever. I'll share the links in this document.
Because
means the book title.
Okay. I
But you
will not be able to buy them. So is there a free download or what is it?
There could be. There could be. Just type with the title, book title. You might get a ebook, PDF book.
Okay.
But these things, whatever slides I'm running through now, I'll be sharing with you. As and when the class is complete, I'll be sharing with you. But I would expect you to download the software, have it ready in your PC, and then by Monday.
Okay. Yeah, by Monday.
By Monday, by the next class, I mean to say. And then I'll first 10 minutes will take to set up the environments. This is pretty easy. It doesn't take much time. Once you download and keep it ready, I'll explain you how to set up the environments.
What is a good operating system for Hadoop?
You would have Windows 7.
Windows 7. Okay.
Yeah. See, now we're not actually dealing with a huge cluster here that anyhow you can't do. You can't afford to have. That is a different ballgame altogether. But you could have the pseudo environment that look like the realistic Hadoop environment. You could run all the components of Hadoop in your PC. That's what we're trying to do. So this virtual machine, if you download it, this is the virtual machine, and this needs the VM to play it, the virtual player, and that's the reason I'm giving a sequence here. If you follow the same sequence and keep it ready, I'll explain you how to set up the things there on Monday. Okay.
Okay.
So we'll meet on Monday then. Thank you all. Thank you. Yeah, one more thing before we wrap up. You could share your email IDs to the organizers. They'll send the email IDs. Once I have email IDs, I can send directly to the. I can directly send you materials and samples, anything which I want to share with you. I can send you on the same day.
Yeah.
Okay. Thank you all. Sharada, are you there? You have any question? I think she's unmuted. Okay, no issues. We'll meet on Monday then. Thank you all.